All right, y'all. So, as you know, I am not here today. So, couple of things. You do still have a warm up like normal. So, once class starts, make sure you've grabbed your warm up. And after we get done with the notes, I will give you some time to work on the warm up. So, you'll kind of do that as soon as you're done with the notes. And then you'll have a classwork worksheet based on the notes that will be turned into the sub before you leave. Okay, so you'll hold on to your warm up. We'll go over that tomorrow. You will turn your classwork worksheet into the sub before you leave, and then you have a Mix 6 for homework tonight. Okay, your classwork worksheet will be turned into the sub before you leave. All right, don't try to hold on to that because you didn't finish it and didn't do what you're supposed to do in class. All right, just a reminder that your behavior while I'm gone is a quiz grade. So remember, your job is to be likable, respectful, and on task. Please make sure that your phones are away. The calculator caddy is the best place to put them. However, I know some of you, for a sub, definitely may not do what you're supposed to do, but it would be in your best interest to do that now. Okay, so just a reminder, again, worksheet goes to the sub before you leave. All right, so we're going to talk about composition of functions, which is something that we've actually already done in a couple of warm-ups throughout the course. So bear with me. I don't have a hard copy here at home with me of the notes. So I am writing on my iPad, so sometimes it's going to be a little off as far as how I have to move things around. Like, for instance, there's not a big gap right here for me to write to do example number 1. I'm just going to kind of do my work over here, but I do have a little bit more room on this iPad and this program, so it doesn't really impact me that bad. Okay. All right. So sometimes in math, we will plug in a value for x into a function and then use the output, the answer, to plug into another function. When we plug the output of one function back into the function, this is called a composite function. Okay. So again, we've done these. We've done f of g of x, things of that nature is what you've done before. And that is what we will get to here past example number 1. So let's look at example number 1 first. Let g of x equal 3x plus 1. Let g of 2 equal c. They want you to find g of c. Okay, so g of 2 equals c. So the first thing we need to calculate here is going to be g of 2. So again, I'm going to come over here and do this because I don't have that much room to work on this note template. All right, so I'm going to do g of 2 is going to equal 3 times 2 plus 1. So we know 3 times 2 is 6, 6 plus 1 is 7. So g of 2 equals 7. Then it says find g of c. Well, we know g of 2 equals c. So basically, we're going to take the 7 and find g of 7. So that's going to give me 3 times 7 plus 1, which is 21, plus 1, which is 22. So our final answer to that question would have been 22. So we had to find the first one, and then we take the one we find and plug it in to find the second one. All right, composite functions. There are 2 ways that we can write composite functions. The first is kind of like the word fog, and then your x after it. And then the second is the way that we write it most of the time, is just multiple parentheses there. So it's the same thing. So this is f of g of x, and this is f of g of x. So either way, it's going to be the same, and we read those exactly what I said, f of g of x. Apologize for my voice as well. Harper had a football game Saturday, tournament today, so been a lot of yelling for me this weekend. All right, so when working with composite functions, we start on the inside or the right. Okay, if we're given f of g of x, we're going to evaluate g of x first. So you start here and we move out from there. Okay, use the answer from g of x and plug that into f of x. Again, we have done this in our warm-up, so all of these steps and things of that nature should not be super confusing to you. All right, so example number 2. F of x equals 3x minus 5, g of x equals 2x plus 1, and they want you to evaluate the following expressions. Okay, so the first thing I'm going to notice is my f is 3x minus 5, and my g is 2x plus 1. Okay, so those are the two that I'm going to be using. So make sure you're plugging into the correct function whenever you're evaluating these. Okay, so the first thing here says f of g of 3. So again, I start with g of 3. So I'm going to do 2 times 3 plus 1. That's going to give me 7. So now we're going to use 7 to go into f. So f of 7 is going to be 3 times 7 minus 5. 21 minus 5 is going to give me 16. So our final answer is f of g of 3 equals 16. All right, I'll try to pause occasionally, make sure everybody's keeping up with me. I do know I move a little fast, and it's going to be even faster because I'm not communicating with y'all or interacting with y'all throughout the notes. So I'll try to pause occasionally and let y'all make sure you're on board. However, I will say I will have this video up in your Canvas at the end of the day, probably around 2 o'clock once third period has had a chance to do this. So that way, if you did need to go back and look over something, you can do that. All right, letter B. So we're starting here with f of 3, which means I'm going to use the f function and I'm going to plug in 3. So f of 3 is going to give me 3 times 3 minus 5. 3 times 3 is 9. 9 minus 5 is going to give me 4. So that's f of 3. Now I want to do g of 4. So g of 4 is going to give me 2 times 4 plus 1. 8 plus 1 gives me 9. So our final answer is g of f of 3 equals 9. All right, so I'm going to pause for a second, let you try letter C. Still using the same two functions. You're choosing the same function twice. So you'll plug it in for f of 4. And then once you get that number, you still plug it just back into f. Okay, good for that. Don't be sitting there waiting on me to do it. All right, so if I do f of 4, so starting with f of 4, so that's going to be 3 times 4 minus 5. So 12 minus 5 is going to give me 7. So I'm going to take that 7 and put it right back into f. So now f of 7 is going to give me 3 times 7 minus 5, which is going to give me 21 minus 5 is 16. So then our final answer here is that f of 4 would equal 16. All right, so using this example to determine whether the composition of functions is commutative. Okay, so what that means is, would it matter which order they were done in? Would you yield the same result? And when you look at these, and I'm going to have to I'm going to go over here and write my answer, because I'll never fit my answer into that little space. Okay, so this is my answer to using this example to determine whether the composition of functions is commutative. Okay, our answer is in fact no. Okay? Compositions of functions in general are not commutative because when we did f of g of x, it did not equal g of f of x in all cases. Now, occasionally you'll find one that does. It may, but it does not have to. Okay, so in example 2, we did f of g of 3, which equaled 16. But when we did g of f of 3, that equaled 9. These did not yield the same result. Okay, so again, there will be occasions where we do f of g of x and it does equal g of f of x, but that doesn't happen in every single case. Therefore, no, compositions are in general are not commutative. Make sure everybody's got time to get that written down. All right, so now let's go to example number 3. All right, using the equations for f and g from example 2. So I'm going to rewrite those because I don't want to have to keep scrolling back up. Okay, so using the examples, f and g from example 2. So in example 2, f was 3x minus 5. And g was 2x plus 1. Yeah. Okay, so those are what we're using. Okay, find the following: f of g of x and g of f of x. So this time there's no numbers. Again, we've already done these in some of our warm-ups. This is one of the reasons why this lesson is the one I chose to do while I wasn't here, because this should not be completely new topic material for y'all. Okay, so if I do f of g of x, that means I'm going to take g and put that into f. So g is 2x plus 1, and that's going to go into f of x. So we're going to do f of 2x plus 1. So that's going to give me 3 times 2x plus 1 minus 5. And now we're going to simplify. 6x plus 3 minus 5 is going to give me that f of g of x equals 6x minus 2. Okay, nothing new. Now we're going to do the same thing for b, except for this time we're going to do f into g. So this time f is going to go into g. So I'm going to do g of 3x minus 5. So that's going to be 2 times 3x minus 5 plus 1. All right, which is going to give me 6x minus 10 plus 1. So g of f of x equaled 6x minus 9. All right, so next example. Lots of different stuff going on here. We've got 4 different functions up here. We've got h, k, p, and m. Okay, so make sure, again, that you're using the correct function for everything you're doing. Start on the inside, work out. All right, so I'm going to do letter A, and then I'm going to give you a few minutes to do letter B and C. B and C, remember, are written the same way. So, again, h of n, so this is the same thing as h of m of negative 1 and k of p of x. All right, so I'm going to start with letter A. I'm going to start with h of 2 is the first place I'm going to start, right here. So h of 2 is going to give me 2 times 2 minus 3. And 4 minus 3 gives me 1. So now I'm going to take my 1 and I'm going to plug that into the k function, which is right here. So k of 1 is going to equal 1 squared plus 4 times 1 plus 5. And we're going to evaluate that. 1 squared is 1. 4 times 1 is 4. 1 plus 4 is 5. And 5 plus 5 would give me 10. So our k of h of 2 value is 10. All right, so I'm going to pause here, give you a few minutes to work on B and C. Make sure you're working. If you get done with B, check your answer with a neighbor, see what they got. If you disagree, see where you went wrong, see who's right. Don't just assume they're right. All right, so I'm going to work out B. You can continue to work on C, and you can check your B with mine once you finish. All right, so for B, I got -5. Let's go over here and look at C. So I'm going to start with P of X. Oh, P of X is its function itself, so P is going to go into K. So here is P. So we're going to do K of the square root of 3x plus 1. So that's a lot going on there. Okay, so that's going to be the square root of 3x plus 1, quantity squared, plus 4 times the square root of 3x plus 1 plus 5. All right, so simplifying this out, we know that when we square a square root, the radical cancels itself out. So these both go away, and we just get 3x plus 1 plus 4 times the square root of 3x plus 1 plus 5. And then combining like terms, we can combine the 5 and the 1. So your final answer is going to be 3x plus 6 plus 4 square root of 3x plus 1. And that's your entire composition of K of P of X. Okay. All right, so example number 5, given f of x is 1 over x squared, and g of x is 4 over x minus 1, find f of g and its domain. All right, so we're finding immediately f of g of x. So that means f of 4 over x minus 1. So f of 4 over x minus 1 is what we're doing. Okay, so that's going to give me 1 over 4 over x minus 1 plus 2. All right, so common denominator on the bottom, common denominator on the bottom is going to be the x minus 1, just for the bottom fraction, okay? So if I do that, I'm going to have 1 over. Well, the 4 already has the x minus 1. So that one's going to stay 4 over x minus 1. But the 2 does not have the x minus 1. So I've got to multiply the top and the bottom by the x minus 1. All right, so now that we've got a common denominator here, we can leave, again, the top still 1. So now the common denominator, so we can do 4 plus 2x minus 2 over x minus 1. All right. So far, if I simplify that, so now we're coming down to here. Okay, if we're coming down here. So 1 over 4 minus 2 is 2. So that's going to be 2x plus 2 over x minus 1. So we have a complex fraction still. Okay, so we're going to kind of flip that. Keep, change, flip. So this bottom is going to flip upside down. So it's going to be basically the 1 on top times, we're going to flip that to x minus 1 over 2x plus 2. All right, which if you multiply out, does in fact just give me x minus 1 over 2x plus 2. So that is our value for f of g of x. Okay, but it also asks us up here to find the domain. So one thing I need you to notice about the domain in this situation, okay, this is all the x's. It's not just all the x's in general, okay? This is all the x's in the domain of G. Okay, G is our inside function in the domain of G that are also in the domain of f of g of x. Okay, so if you look at that, let's go back to your very original. Okay, if you look at this right here, all right, our domain of f here, or I'm sorry, this is g, domain of g in general, 4 over x minus 1. The domain of that is everything up until 1, right? So negative infinity to 1, union 1 to infinity. Okay, that would be the domain of g. Down here, if we have this denominator, if we set that equal to 0, 2x will equal negative 2, and x cannot equal negative 1. Okay, well, negative 1 is included in the domain of g, but it cannot be included in the domain of f of g. So then our final answer for our domain is going to be from negative infinity to negative 1, union negative 1 to 1, union 1 to infinity. So negative 1 worked in the original, but when we did the composition, negative 1 became something we could not have. So this is your final answer for your domain. Okay? All right. So now let's look. Let me see if I can move that. Oh, yes, I can. Okay, sorry. Oh, no, I can't. Boo. Oh, goodness, y'all. Done messed up. Y'all quit laughing at me. I know you're laughing. Okay. I don't know. Can I move him now? All right, let's try it now. Let's see. Can I move? Nope, still don't work. Oh well. All right, about to. Let's just delete it. Okay, y'all got that answer. Hopefully. Sorry, trying to do too much. Okay, here we go. All right, so example number 6, the graph of the function f of x is given above along with a table of selected values for the function g of x, an equation of the piecewise function h of x, and a verbal description of the function k of x. Use this information to evaluate the following if possible. All right, so we've got all of this stuff going on. Okay, so be mindful here. Again, we've got a graph. Okay, we've got a table. We like tables. We've got a piecewise function. Favorite things ever. Okay, and then we've got this right here. Okay, let's talk about what that means right now. Right, let's just talk about what this right here means right now. K of x is a quadratic function. Okay, so we know quadratic has to be squared with a horizontal translation of 2. Horizontal is inside, so that's going to be x minus 2 squared. Followed by a vertical translation of -3, so that's going to be vertical translation, not dilation, so translation is going to be -3 onto the end of that. So that is what they're saying k of x is. Okay, so it is expected that you can turn those words into a function. Okay? All right. The graph of the function, so we've already done all these. Okay, so they want us to find f of g of 3. Okay, so we're going to start at g of 3. Well, where's g? Okay, g's up here. Right? Do we have a 3 in our x value? Do we have a g of 3? We do not. Okay, and we cannot create that if we're not given it to us in this situation. Okay, so we're going to say g of 3 is not defined. Okay, we didn't have a value for g of 3. Therefore, we're going to say that f of g of 3 is not defined. And you're done. Okay, you can't create it if it's not there. All right, let's look at letter B. H of f of 8. So the first thing we want to do is look at f of 8. Well, when I look over here at f and I go over to 8, I do have a value there. That is -1. So we know f of 8 equals -1. All right, then h of -1. All right, so h is this piecewise function. Okay, well, -1 falls in the category of less than 1. So we're going to use the top equation. So we're going to do h of -1 to be the absolute value of -7 plus 3 times -1. All right, 3 times -1 is -3. -7 minus 3 is -10. And the absolute value of -10 is going to give me +10. So I should have written, sorry, waste space there. Okay, so h of f of 8 is 10. Okay. All right, g of k of 0. All right, so we got to start there with k of 0. So k of 0 is going to be this right here. So 0 minus 2 squared minus 3. So -2 squared is 4. 4 minus 3 is 1. And now we're going to do g of 1. Well, g of 1 is going to be up here. G of 1 is not defined. We don't have a value for g of 1. Therefore, we have to say that g of k of 0 is not defined. Okay? All right, so you take a second and look at D, E, and F. And I'll go ahead and tell you only one of them is not defined. D, E, and F. Okay, so take a minute. Well, just look at D and E first. F's a little confusing, so we may walk through it together. Okay, so D and E. They're both defined. F is not going to be defined. We'll talk about why whenever we get there. Okay, so go ahead and try out D and E. If you're stuck, talk with a neighbor. See where they're at. All right, let's look at F of 2. So F of 2 is 1. Okay, F of 2 is 1. So then F of 1 takes us all the way up here to 4. So F of 1 is 4. So therefore we can say F of 2 equals 4. All right, G of H of 1. So let's look at H of 1 first. Well, H of 1, okay, is right here. H of exactly 1 is negative 4. So H of 1 equals negative 4. So now we're going to do G of negative 4. If you look up here, G of negative 4 actually gives us a value of pi. So we finally have a value on our G function. Therefore, we can say G of H of 1 equals pi. Okay? All right, so letter F. Let me hide this. There we go. Okay, letter F. So we're going to start with most inside function, right? Okay, so if I was to write this out using our regular notation, I'm going to have to kind of zoom in and zoom out and move all around for this one, y'all, so we have room. Okay, if I was to rewrite this using the other notation, okay, it would be, we would start with K of 3, right, on the inside. Then we would move out and we want to do H of that. Then we move out and we want to do F of that. Then we move out and we want to do G of that. So that is what that would look like if you were to write it out with parentheses versus the little circle in the middle. Okay. All right. So we're going to start again with K of 3. So K of 3 is going to be 3 minus 2 squared minus 3. 3 minus 2 is 1. 1 squared is 1. 1 minus 3 gives me negative 2. So we're good so far. Then we're going to do H of negative 2. So literally you're just going piece by piece. So H of negative 2. Well, negative 2 is this less than 1 side. So that's the absolute value. Absolute value of negative 7 plus 3 times negative 2. All right, so 3 times negative 2 gives me negative 6. Negative 7 minus 6 gives me negative 13. And the absolute value of negative 13 gives me positive 13. All right, then we're going to do F of positive 13. Okay, well, if I go back up here and I look on here, I don't have a 13 on my graph. Therefore, F of 13 is, in fact, not defined. And if that one is not defined, then we can say about the entire thing, G of F of H of K of 3 is not defined. Okay? So again, we were good to go until that very last one. We didn't have a value for F of 13, so therefore we are not defined for the entire composite function. Okay? All right, so the very last thing we need to talk about. All right, when you decompose a composite function, you're finding the components of the composition. Look for an inside function and an outside function. Okay, so we're looking for an inside function and an outside function. All right, so for each function h, find the functions f and g such that h of x equals f of g of x. So we want to know what is inside here. Okay, so what would be inside here is going to be our x plus 3. So this is going to be our g. And then our outside is the entire thing squared. Okay, so our inside on letter B would be the x minus 5. So then the entire function would be 1 over x. Okay, so if this is our g, this makes sense, okay? If this is our g, and this is our original function, if I do f of g, do I get this equation? If I put this into this, do I get what h is? Yes, because this right here would be my denominator, and that's 1 over x minus 5, which is what h is. All right, so for letter C, our inside function would be x plus 2. And then your outside function is just the square root of x. So again, if I put g into f, do I get h? I do. And then for D, our inside function is kind of what's in our parentheses, so x minus 2. And then we would have that squared minus 4 times that plus 5 would be our outside function. All right, so we're going to pause the video here. Okay, you're going to pause my video here for about 5 minutes. Okay, and you're going to try all of these examples for me. Okay, actually, we'll stop the video here. Okay, I'll stop the video here. So you're going to work on these U-tries first. Okay, and once you work on the U-tries, I will. No, just rewind. Change that. I don't want to do it tomorrow. So I'm going to pause the video here. Okay, or you're going to pause the video here. And in about 5 minutes or so, okay, somebody just hit play again. And I will flash up here the answers to these questions. Just the answers. I'm not going to have all the work and everything. If there's anyone you missed, you can ask me about it tomorrow. And then the sub will pass out your worksheet, which is just a big 10 on composite functions. And then is to be turned in before you leave. And then your homework is the Mix 6 on, I think it's 2.1 to 2.2. I'd have to double check that. And then we'll have a 2.3 to 2.4 later this week. Okay, so go ahead, pause the video here. Somebody come up here and pause the video. And then here shortly, hit play again. And it will show you the answers to this. Okay. All right, y'all, so here you go. All right, right here are our number 1 answers, number 2 answers, number 3 answers, and number 4 answers. If you got any questions on those, again, you can ask me tomorrow. And again, this will be on your Canvas later this evening. Okay? All right, make sure you get your work done. I will be back tomorrow. Can't wait to see you all. Make sure you're dressed out for Spirit Week this week. And I will see you on Tuesday. Y'all have a wonderful evening.